Real quick on our bell ringer here, what's the vertex of that V? -3, -6. What's in with the X is always the opposite sign, and then what's stuck on the end is what it is. We're fixing to look at a quadratic function today, and that's the same. So if this were a quadratic function, the vertex would be exactly the same, except it's going to make a U instead of a V. Yes?
Is your class gonna have a semester test?
I don't know yet. They've not told us all. This class we want a semester test. If we have semester tests, yes, it's required, but they've not told us yet if we are.
I have to take them because I have appendicitis. That's so early.
Alright, so we would go, I'm not gonna draw it over there on the graph they provided, because I can't see those lines very good. So I would go left 3, and up, or excuse me, down 6. Away, so we're looking at that. Now, you could type it in your calculator and go look at your table and plug those values in if you wanted to. I put -3 in the middle. To the left of that, I could do -4 and -5. To the right of that, I could do -2 and -1. So let's just do those mentally real quick. -5 plus 3 is -2. Absolute value, -2 is 2. 2 minus 6 is -4. So I would have -5, -4, right out there. Okay, -4 plus 3 is -1. Absolute value, -1 is 1. 1 minus 6 is -5. So that one would be about right there. Okay, I already got my -3. -2 plus 3 is 1. Absolute value of 1 is 1. 1 minus 6 is -5. So there. And then -1, I bet it's -4. -1 plus 3 is 2. Absolute value 2 is 2. 2 minus 6 is -4. So you get something looking similar to that. That was bad. Well, you know, now I'll just make it worse and worse every time. Alright, you alright on that, other than my messiness? I'm gonna erase that and we'll get started with some quadratics for today. Which is why I was telling you it's exactly the same. Once you learn those transformations and the vertex and all that for one function, it's the same for all of them. Makes it easy schmeezy. Alright, so standard form of a quadratic. Get a white marker and get rolling here with you. Standard form of a quadratic. You're going to hear this a gazillion and a half times. F of x, which is the same as y, ax squared plus bx plus c. Okay, so a quadratic, its highest power is always 2. So you're looking at things being squared now. Your highest power is always 2. A, B, and C would be actual numbers. The graph of a quadratic is a parabola, which makes a U. So same as with absolute value functions, we'll either have an upright U or an upside down U, depending on your A. Just like with an absolute value, if your A is positive, your U will go up. If your A is negative, your U will go down. Okay, same stuff on all that. Alright, so the reason this is going to be so easy for you, if you're going to put up, is that these are just like V's in that their vertex is on the axis of symmetry. It's in the middle of it. So the formula for finding the x of your axis of symmetry is you do -b over 2a. Alright, that's pretty important. That's the x of the vertex, which is also called the axis of symmetry. It's where you could fold that U and it'd be exactly the same on both sides. Okay, now, other things that we're going to discuss as we do this is a minimum value and a maximum value. The minimum value and the maximum value, if you look at the two little examples I gave you over here, will be the y of your vertex. It's a minimum here when your A is positive because it's sitting on that, so a positive A. It's a maximum here when your A is negative because it hits its head on that, so a negative A. That will tell you if you have a minimum or a maximum. The vertex, just a lot of new terms for you, we're fixing to see what all this means. The vertex, that point in the middle, is also called the turning point. Because if you like, I always say when we get into a lot of graphs, if I ride my bicycle on the graph, so over here where my mouse is on this upwards one, if I jump on my bicycle, I'm going downhill, 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 until I hit the vertex, then I turn and start going uphill. So that's called a turning point. Alright, so those are all the defos that we got to get out of the way. You ready to do some work now?
No. So,
Yeah, you got a late start because you're playing on your phone. Use wood in the wood, everybody else good? Alright, so let's say that we have f of x equals 4x squared. So here's what we're gonna decide. If it has a maximum or a minimum, we're gonna find the axis of symmetry, and we're gonna find the vertex. Okay? Alright, so we wrote a formula for finding the axis of symmetry. Formula for finding your axis of symmetry is that x is equal to negative b over 2a. And that's from standard form of ax squared plus bx plus c. So what is our b up here in this equation? It's not a trick. B is the number in front of our x to the first. So what do we have there? Mm-mm. 0. We don't have an x to the first.
sorry.
So our b is 0. Good. Over 2 times, what's our a? Your a is how many x squareds you have. How many x squareds do we have?
4.
4. So we've got, and what is 0 divided by 8? 0, very good. So our axis of symmetry, to put my answers up here, would be at x equals 0. So that's on the origin. That means that y-axis would be the middle of our parabola. Now, our vertex, just like on a V that we did, is going to be 0, comma, something. So how do I get that something? Same as with the vertex. How do we find the y on a vertex with an absolute value function? We got our 0. How do we get the y? We did it on absolute value functions the exact same way. Once we got our x of our vertex, what do we do with that to get the y? Plug it in. Very good. It goes in where the x is. So my y is going to equal 4 times 0 squared. Well, 0 squared is 0. 0 times 4 is 0. So my vertex is at 0, 0. So at the origin. So this is a nice parabola sitting at the origin. Last thing I ask us to do on this is to tell whether or not it's a minimum or a maximum. So if it's going to open up, it's got a minimum. If it opens down, it's got a maximum. And your A tells you that. If your A is positive, it's a minimum. If your A is negative, it's a maximum. What's our A? Our A is positive 4, right? So it's a positive A, so we're going to have a minimum. And we're working our way up to graphing. We're not ready yet. Okay? Everybody all right on that? Okay, I'm going to give you an equation and ask you to do all those same things. So, you're...
Wait, I need you to go back.
I got you some magic.
Oh, just kidding.
Okay, let's say we got f of x is equal to negative x squared plus 6x. I want you just to tell me if it's a minimum or a maximum. I want you to tell me the axis of symmetry. And I want you to tell me the vertex. Bless you. See if you can get those 3 things figured out. Go. Give it a try. Give it a try. start you for the axis of symmetry.
For the axis of symmetry, would this be 2 times 1 or 2 times negative 1?
2 times negative 1, very good.
I'm having a hard time on the vertex. Like I got my axis of symmetry, but what would I do to find the vertex?
You'd have to plug your axis of symmetry back into both of the x's.
What is the axis of symmetry?
The middle of the parabola. It's the x point, the middle.
Oh, okay.
Alright. You can. I don't know if we do or not. No, we don't. Let's see here on our, remember our formula for axis of symmetry is negative b over 2a. So I'm gonna do negative, what's my b? What's my 6 over 2 times, what's my a?
Negative 1.
Okay, so that gets me negative
Negative
6 over negative 2. And negative divided by negative is a positive, so you get an axis of symmetry of 3. Everybody all right on that? Anybody need help there? Okay, now when we go to plug that back in to find our vertex, we have 2 places to plug it into this time. So we'll have negative, and that negative is just stuck out in front. It's not on our 3. So we'll do negative, then we'll do our 3 squared plus our 6 times 3. Okay. Marker go, try to scroll a little bit. Alright, so 3 squared is 9, but then you make it a negative. 6 times 3 is 18, so that gets me 9. So when I write my vertex, my x was 3 and my y was 9. How'd you do on those 2 pieces? Get them? What'd you do wrong, Kinley?
The negative on the, thing. I wanted to do negative 3 squared.
Okay, yeah.
so-
Then that's a common mistake, but when it's just stuck out in front like that, does it make sense how now? Okay. Okay, excuse me, now is that a minimum or a maximum? Max, very good, because my A is a negative, which
Oh.
means it's opening down. So, shouldn't have put a peanut in my mouth. So it is a maximum, very good.
Where,
Alright, next, we're gonna look at actually putting them on a graph.
head coach,
Yep.
How would you get the, you said you're, never mind, I figured it out. I figured it out.
Well, thank you, I'm glad I could help. Alright, so, let's get a new page. No marker, there's no marker.
Are we gonna do, graphing today?
Right now. Get my paper white, so I can get a piece of graph paper. Okie dokie, let's do f of x equals negative 3x squared. Okay, so our steps for graphing, same as on a V. First thing we did when we were graphing on a V is we had to find the axis of symmetry, we had to find the vertex. So, to start, it's always negative b over 2a. So what's my b? Like the first problem that we did.
0.
0, very good. Over 2 times negative 3, well 0 divided by anything is 0. So that means this is gonna be the center of my U, right? Now I plug that 0 back in. Negative 3 times 0 squared, 0 squared is 0, 0 times negative 3 is 0, so our vertex is on 0, 0. Okay, if you'll remember when we did the V's then, since we knew that was in the middle, we put that down here in the middle. Now we pick a couple to the left and a couple to the right. Okay, so if I come over here to my equation and I plug my negative 1 in. Negative 3 times negative 1 squared. Negative 1 squared is 1. 1 times negative 3 is negative 3. Oops, I wrote that on the wrong one, dumb butt. Dummy, dummy, dummy.
Wait. Just kidding.
Negative 1 squared is 1, 1 times negative 3 is negative 3. Okay, now if I plug my negative 2 in, negative 2 squared is 4. 4 times negative 3 is negative 12. Okay, now I'm down here to my 1, and this is just like with the V's. I'm expecting some magic here when I plug my 1 in, because this is in the middle. So negative 3 times 1 squared. 1 squared is 1 times negative 3 is negative 3. Okay, let's see if our 2 gets us negative 12. Negative 3 times 2 squared. 2 squared is 4. 4 times negative 3 is negative 12. Alright, so all we gotta do now is plot those, and we've got our parabola.
I have a question.
What you got?
What is the thing above, 2a? Like that?
Negative b, that's a b.
Okay, so,
Alright, so I got my 0, 0 already. So I'm gonna scroll this down because we're counting down to the negatives. So I'm gonna go.
Do we put arrows at the end of it?
Yes, just like these do go forever. So I'm gonna do negative 2, negative 12. 9. Put a little line there so I know that's at 9. Oops, I'm not 9, 10, 11, 12. Okay, I also had 2 12, so while I'm down there, let me make that one. Okay, then I had negative 1, negative 3, and I also had 1, negative 3. So, these are not V's anymore, and sometimes it's real hard to draw them so that they look like U's, but try to make your vertex be rounded, and, oops, that got off of it, be rounded and not a point anymore. Sometimes it's difficult. Okay, they do go forever like Kinley was talking about. Now, let's talk about domain and range. Okay, even though this one's real narrow, it is gonna keep getting wider to the right and wider to the left. So just like a V, your domain on these is always gonna be all real numbers. The only time it ever won't be on a parabola is when it's a sideways parabola, and we're not ready for those for a while. The range, just like the V's, are gonna be wherever its vertex is. So my range goes below this vertex, so my range, my Y's have to be less than or equal to 0. See how it's all, it makes it easier doing this now that we're real good at the V's. It all hooks together like that. Okay, I'm gonna do one more with you, and then I'm gonna let you try one. Circle on that. So I'll remember what we did. And you can also graph them in your calculator and use the table, just like we did with the V's. If you've tried that, that should work as well. Alright, let me get a white piece of screw paper for my graph. Oops. Now, let's go get my graph paper. Okie dokie, choo. I got f of x equals x squared minus 6x plus 11. So the directions here say to graph, then give the domain and range. Now, we're gonna learn different forms, just like with the absolute value functions, we learned vertex form. So we're gonna learn different forms with these parabolas, these quadratics as well. But when they're in standard form like this, the way to start is always to find your axis of symmetry, which is always negative b over 2a. As we learn different forms, there'll be different ways to start, but for standard form, this is how you're always gonna start. Yes, Kim?
If you have a negative b, but it also wants a negative, would it make it a positive?
And that's what we got right here. So there's a couple of ways we could write that. I'm gonna go ahead and put my negative out there, and then my negative 6, but Kinley's right, you know that negative times a negative is what I'm fixing to deal with. So my a is 1. Everybody okay with how I set that up? Okay, now here's what Kinley was talking about. We got a negative by a negative, so that makes that a positive, and 6 divided by 2 is 3. Okay, so if you start thinking about making a table here in a minute, I'm gonna put 3 in the middle, go a couple to the left of it, and a couple to the right of it. Okay, let's go ahead and plug that 3 into both of our x's up there now to find out what our vertex is. 3 squared minus 6 times 3 plus 11, so that's 9 minus 18 plus 11. 9 minus 18 is negative 9, plus 11 is 2. So we got a vertex at 1, 2, 3, 1, 2. And that's also where that axis of symmetry would be. Don't have to draw it if you don't want to, but that's where it would be. Okay, everybody all right on that?
Hold on.
You got it, sister. Alright, so now I'll go to the top of my chart now, I'll plug a 1 in. 1 squared minus 6 times 1 plus 11. So that's 1 minus 6 is negative 5 plus 11 is 6. 2 squared minus 6 times 2 plus 11. So that's 4 minus 12 is negative 8. Negative 8 plus 11 is 3.
And you should get 3 and 6 for the other two.
Yep, so I should get 3 and 6 for those other ones. I wrote it already, but let's check them just to make sure. 4 squared minus 6 times 4 plus 11. That is 16.
You get 3.
Minus 24 is negative 8, and negative 8 plus 11 is 3. So I think we're pretty good on our points. Y'all think we're all right? Ready to graph? Over 1 up 6. I'll go ahead and go over 5 and up 6. Well, no, over 2 up 3. Already got my vertex. Over 4 up 3. And then over 5 up 6. not to make it pointed, because we know the difference between an absolute value and a quadratic. Very good. How'd you do? Domain, don't miss domain on these, it's a given.
All real numbers.
All real numbers, range.
Wouldn't it be y equals or greater or equal to 2?
You got it, sir. Okay, is that parabola, is that quadratic a minimum or a maximum?
Minimal.
Minimum, and I didn't ask you that, but I'm just throwing it at you now, it is a minimum. Now what if it said, what is the minimum?
Would it be 2?
Yes, it corresponds with the range. So the minimum, the lowest it goes is 2. Very good. Very good, very good. I think y'all ready to try one. Okay, got what you need on that one? Wait a second. Alright, let me get a piece of white paper. Page. There we are. Alright, one you're gonna try real quick. Come on, papers show up. I'm clicking you. Try this real fast. There you go. Alright. Says f of x equals 2x squared minus 8x plus 6. Let's give me a graph, a domain, and a range. See what you can do with that. All I've done is found the vertex and the axis of symmetry, so just go back and look and make sure you got those right. where you don't have to use the points I'm using. I just use those because they're easier, like Austin pointed out. Okay, how'd you do on just the graph part? Any questions on just the graph part? Good. What's the domain?
All our numbers.
All real numbers. What's the range?
Y equal.
Very good, very good, very good. Did anybody practice doing it in your graphing calculator? Good, 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 good. That's just as good, works faster and easier. Last thing I wanna look at with you now is an inequality, just like we did with other stuff. So instead of saying y is equal or f of x is equal, we'll say y is greater than or whatever. So remember that means there's gonna be shading. So just thinking ahead, that means you're either gonna shade inside the U or outside the U, okay? Make out what you need on that, we'll still see a couple writing. Can y'all believe it's already November? It's not long. I'm one of those that can't start Christmas until Thanksgiving's over, though.
Right?
I enjoy
My mom's
Thanksgiving.
decorating our house this weekend.
No, I enjoy Thanksgiving too much. You can't, I enjoy Christmas, but you can't skip Thanksgiving. Oh, I thought I picked white paper. I didn't.
I asked her.
Wow.
I know. Now you know why I gotta pick white paper every time. Alright, let's look at y is greater than x squared plus 2x minus 2. Alright, we'll do this one together. We're gonna start the same. Things that will be different when we get there is we'll connect our points either with a solid U or a dashed U, and then we'll shade either inside the U or outside the U. But everything else, the process is still the same, so you could still use your calculator to get the points in the table and all that type thing. I'll start with my negative b over 2a. So that's negative 2 divided by 2, so that's negative 1. So here's my axis of symmetry. Now just plug that negative 1 back in to get my y. So negative 1 squared plus 2 times negative 1 minus 2. 1 minus 2 is negative 1. Negative 1 minus 2 is negative 3. So my vertex is at negative 1, negative 3. 1, 2, 3. Alright. So now, if I'm doing this by hand, I'm going to put negative 1 in about the middle, Go a couple to the left and a couple to the right. So negative 3 squared plus 2 times negative 3 minus 2. So that gets me 9 plus negative 6.
Wait, I have a question, what are we doing here? Checking this for?
I am finding other points so I'll know where to draw my V. So once I get my axis of symmetries in the middle, I pick 2 to the immediate left and 2 to the immediate right.
Okay, if you type the equation into our calculator, it would just give us this. and
Go to
then
the table. Alright, so 9 minus 6 is 3 and 3 minus 3 is 0. Negative 1 squared plus 2 times negative 1 minus 2. 1 minus 2.
We already did that one.
Oh, yes, thank you, that's the vertex. I was fixing to do the vertex all over again, thank you, Kinley. So then these should be, you know what these are?
0 and 1.
Are they?
Oh, no.
I don't know.
It's not what I
Okay,
thought.
negative 2.
Oh, that's negative 2 and then that one is, I don't know.
I got one, negative 2, negative 3, negative 2.
Yes,
1.
Summer and Austin are correct. My negative 2 up here should be negative 2. I don't even have negative 2 written over here. When did I even do that to put a 0? I don't know, but thank you, Summer and Austin, for fixing that. Did I try to do it mentally and screw it up? What happened? Do y'all remember?
I don't know, Coach.
Okay, so then what would my 1 be?
1.
Alright, so we got negative 1, 2, 3, 1. Negative 2, negative 2. Already got my vertex there. 0, negative 2, and 1, 1. Okay, before I connect them, go back and look at the original problem and see if it needs to be solid or dashed.
Wouldn't it be dash?
Dashed, very good, because it doesn't have the bar underneath the sign. So it's just gonna be a dashed parabola. Now I gotta figure out if I wanna shade on the inside of it or the outside of it, and the process is gonna be the same. It's gonna be pick a test point, it's not touching the U, even though it got close.
0, 0.
It's not touching 0, 0, so I'm gonna plug 0, 0 in, which would say 0 is greater than 0 squared plus 2 times 0 minus 2. 0 squared is nothing, 2 times 0 is nothing, so that just reads 0 is greater than negative 2. True or false?
True.
True, so that
So
means
it'd
0,
be inside?
0 is part of my answer. So it gets shaded, it's inside my U, so I would shade inside my U. And that's that. I'm so confused about what I did on that negative 2, but I'm glad Summer caught it and Austin caught it. I don't even have anything written down for it. For some reason I just wanted to put it as a wrong answer. Ah, I got one more for you to try. What was, yes, I can. There we go. Scroll a little bit for you.
Are we gonna do domain
No,
range?
No, they never ask for that on the shaded ones,
Okay.
so we don't have to worry about that. So if you found what you needed, alright. Alright, we got y is greater than or equal to negative 3x squared plus 18x minus 22. So I want you to try that one, see what you get. inside it or outside it. So you gotta pick a test point and plug it in.
To find your, whether it's shaded or not,
Uh-huh.
if I use 0, 0, do I plug 0 in for X?
The X and the Y.
What if it's true? What do we do?
Then is that point inside or outside? Is it inside the U or outside the U? The point 0, 0.
Outside.
So it's outside, so you color outside. Bless you.
So we plug in 0 for X, and then.
And 0 for Y. Okay, my parabola is pretty hideous, but other than the hideousness of it, did you get a parabola that looks something like that? Should it be solid or dashed? I already drew mine solid, is that right, or do I need to dash it?
It needs to be solid.
Okay, it's solid because it had the equal bar underneath it. Now, I wanted to hurry and get caught up with y'all because you were already talking about your shading. I can pick this point 0, 0 because my parabola didn't touch it. That's outside of the parabola. So if that, when I plug 0, 0 in the original equation, if it makes it true, I'll shade outside. If it makes it false, I'll shade inside. So that would say 0 is greater than or equal to -3 times 0 squared plus 18 times 0 minus 22. So 0 squared 0 times -3 is 0, 18 times 0 is 0. So all we're left with is 0 is greater than or equal to -22. True or false?
True.
True, and that's outside, so we shade outside.
William's right here too. Oh, no.
Isn't this beautiful? I'll tell you what, that's horrible. Okay. So standard form of a quadratic, that is the first little intro to you on quadratics, which we will, when we get there full in, like right now we're just looking at a lot of different functions. When we get to quadratics full in, that's gonna be pretty big. Tomorrow, we get vertex form of a quadratic, so just like with the V, it'll already tell you what the vertex is, so there'll be easier ways to start. Okey dokey, chokey.